All right, so let's see if we can get through this one. It's a little bit longer here. We've got two accounts that we're putting money into, and you can see in the chart, they both start out with different amounts, 400, 500. This one's growing by a constant amount. It's going up 75 every time, so that's like simple interest. So that's a little easier to work with here. The second one, or actually the first one here, um, it's increasing as it goes up. So over here it says that it is compounded continuously. So let's remember how that formula looks. So it's P times E to the RT to figure out how much money is in the account. So we'll need to use that there. The second one, because it's linear, growing by the same amount every time, that's where you take your starting amount or like your y-intercept and you add on how much is it increasing each time. So 75 and times t here, the variable, pay attention to that. I think I got this one wrong the first time by using the wrong variable in the formula. And then the balance grows at a constant because it's always $75. So that's a constant rate there. Account one, this is going to be an increasing rate if you look at these numbers. And when you do continuously, because you're earning interest on interest, it does go up each time. But my formula here would be my 400 would be my P, my starting number. But then I've got to have this R. So how am I going to solve to find this R and this T? So if we know the 400, we could go down and let's see if we could put in a T here. So if I have the 400, my E, I don't know the rate, but if I go say to this next year, so this would be 1, 2 down the road here, I know that the amount of money in the account at that point is the 469.4, for example. So I mean, you could pick any of these numbers to do it with. So then to solve that, divide by your 400 here. And then that's going to be e to the RT. So let's see, I'm just grabbing a calculator to actually divide that out. 469.4 divided by the 400. That's like 1.1735 then. And that equals my e to the 2r, or r times 2. Remember, once you get to a base and a power, and the power as your variable, convert it to a log. Log base c, remember that's just going to be natural log, of 1.1735 equals the exponent 2r, and then we're going to take that, divide by this 2, and we'll have our r. So this is natural log, so I'm doing on my calculator, ln of the 1.1735 and dividing by 2, ln 1.1735, hitting enter, and then dividing by a 2, and I'm getting something like 0.07999. So for the formula here, remember your t, don't use for your t, you got to have the t. So it's my 400, this is my base formula. Starting number in the account was 400. E to my rate now, does it tell me what to round my rate to? Use integers or decimals, round to hundredths. So again, I had 0.0799. So my R, 0.0792 decimals, that'd be 0.8. It was 0.0799. So that would say round this up to an 8. And then times my t. So don't forget to use a t in your answer there. All right, so then going on to the next part, will the amount of money in account one ever exceed? Well, yeah, because this is increasing more and more every time, and this is staying the same. Sometime down here, eventually, it's going to be more. So account one sometime grows at an increasing rate. Account two is a constant rate. The balance will begin to exceed that of account two. So then we're supposed to solve for when it happens. And they want to know to the nearest whole number. So this does seem like the right answer. Account one grows at a decreasing rate? No. Account one grows at an increasing? Yes. Account two grows at it's not a decreasing rate. So that's not right. It's a constant rate. account 1 grows at a constant rate. No, it was increasing. And account 1 grows at a constant, no. So it's got to be A, but then we still have to solve this for when they equal. My preference for solving that is to graph these two equations in Desmos, for example, and just look for where the graphs intersect. And that way the calculator has to do all the messy work for us, so to speak. So I'm going to copy those two equations down that I have right here, the 400. Hopefully I can use that rounded off decimal times my e to the 0.08t. And my second equation, the 500 plus the 75t. If I have to be, if it were still wrong when I typed it in, I would just be a little more careful with that 0.08 and go back and use this more expanded out rate and decimal right here. But to solve for this problem, my y equals my 400, oops, 400 e to the power of 0.08. I'm going to use an x now instead, just because I'm in a graphing. And then my second one was y equals the 500 starting amount plus adding $75 each month or year. And then if I zoom out of here, I got to find where these meet over here somewhere. Getting too far out. So it's getting up around 400 or 500 or something up there, 600, not too far over here. So if you go to your wrench, right there, your settings, you can come down here and change your numbers in here. So I don't think we're gonna go negative much, and I don't think it. Let's just go over like 15 and then down here, make my y's start at a negative and go 600s or something. So let's see how the graph looks with that. Click over here. Still making it hard for me to actually see the lines and where they meet. Seems like it was someplace right back. Someplace down here. So it looks like I've got a negative number for my x, which is not what I was really expecting in this problem. But if I click here somewhere, I should be able to tell what that point was. A negative 2.191, 400 e to the 0.07x, and 575t. And if you keep going up here, they keep getting farther and farther apart, so they're not going to intersect again. I was expecting my t to, seems like, did I type something in wrong? 400 e to the rt, 500 going 75. And again, if I go back to that problem, because this was growing more every time, starting at 400, it's growing more and more and more. Eventually, it should catch up to this one. So I'm going to pause this and take another look there to see what we've got going on. Okay, so I think I took a little break there. I had to go look. I couldn't figure out why I was getting that negative x for when the two were the same. So I had to go out and zoom out here further. I had to get my y clear up here, because when I looked down below in the graph down here, it didn't, the only place I found where they intersected, so I had to get my y clear up to 2000, and there I finally found it. So it was at like 20 years there, but I had to get into again these settings, and down here where these y's were, and to get up there just a lot farther on my graph so I could see more of the graph. But the answer that I finally, when I zoomed out far enough, found there again, 20 years, 0.221. So if I was able to use, remember I did round off this 8%, but that, and so that's what I was using here. But the 20.221 221 is what I got there. It said to the nearest whole number. So just to the 20 years is what I would use there.